Welcome to this IB Maths Intense session, Binomial Theorem, our seventh short video looking at the Binomial Theorem. And we're building on what we did in the last session, where we introduced the idea of generalizing with negative and fractional indices. And in this video, we just want to look at a few examples of actually applying the generalized formula that we derived. So without too much further ado, just to recap, we'd said if n is a negative or a fraction or both, let's learn this one generalization. It works for all cases. We think about 1 plus x to the n as being, and what we've done here is we've taken the binomial formula, but instead of having a plus b, we've substituted and made a equal to 1. And instead of writing out the NCR notation, we've written down its alternative form. So NC2 as n times n minus 1 over 2 factorial, just so that we can use that for negatives or fractional terms where we couldn't with NCR. And the other thing to recap on there is we'd said because this needs to be a convergent series, in other words, each term getting closer and closer together, that this was only going to be true or work for cases where x was a value between -1 and 1. So we might get a question that isn't just 1 plus x or 1 minus x. It might be, in this case, 1 plus 2x on the bottom of this fraction. So something of the form 1 plus a to the x, 1 plus ax to the n, sorry. 1 over 1 plus 2x all squared. I've written it like this just so that you can remind yourself that if you see something as a fraction, you can make that into a negative index, which you can then use the binomial for. 1 plus 2x, hopefully you can recall laws of indices, that is the same as 1 plus 2x to the power of -2. And once you've got it into that form, then just fire away with the formula as before. So looking at the formula beneath, highlighted in green, we can now expand this out and say that this generalized form can be written as 1, and then n in this case is equal to -2. So we're going to have 1 plus -2 times, well, not x in this case, it's going to be 2x. Then we're going to have n times n minus 1, so it's going to be -2 times -3 now, all over 2, and then it's going to be -2x all squared, and then the third term will be -2 times -3 times -4, all over 3 factorial, which is 6, and then it's going to be -2x all cubed. And I'm going to stop there, but I could keep going, but I'll normally only have to write the first 4 terms or so. And then it's just about simplifying each of those. First term, -2 times 2x, I'm going to end up with 1 minus 4x, and then do a bit of simplifying here. Now I'm going to end up with a positive value here because I'm multiplying 2 negatives together and I'm squaring a negative, so I'll have plus, and then the 2's can cancel down, so I end up with the 3 times 4. I end up with 12x squared here. Next term will be negative because I've got 5 negatives all together on the top of that expression multiplied together, so it must be negative. I'm going to cancel down my 6 and the 2 times 3, so I'm ending up with 4 times 8, which is 32x cubed as the next term, and then it would be a plus, and then ... will do. So there we go. There's a nice generalized form using the binomial for 1 plus 2x to the -2. Very straightforward, a nice simple generalized formula to remember. You might see something written using root notation, so root all of 1 plus 2x, again 1 plus 2x. Don't forget that this can be written as 1 plus 2x to the power of a fraction, which is a half. So it's just worth a reminder there. And then once you've got it in this form, you can just plug that in straight into the formula exactly as we just did with the previous example. So in here, n is going to be equal to a half. And so our expansion will look like 1 plus, and then n is a half. And the next term will be the 2x, not just x on its own, it's 2x. Then it's going to be n times n minus 1. So a half multiplied by minus a half, because a half subtract 1 is minus a half, and this will be all over 2, and then I've got my 2x all squared again. And then the next term, keeping going, a half times minus a half, and then subtract another 1 makes that minus 3 over 2 this time. And then this will be over 6, or 3 factorial, and then I'll have 2x all cubed on the top, and then plus dot 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 dot. And then it's just a case of working that through and simplifying again. So 1 plus a half times 2 is 1, so I'm just going to have 1 plus x. And then these fractions, I've got a half times a half. This is going to be negative this term because I've only got the one negative there. A quarter divided by 2 is an eighth, and then we're going to multiply that by 2 squared, which is 4. I end up with 4 over 8, which is a half. I'm doing this nice and quickly. Of course, in the exam, you can take your time to make sure you've got the correct result from that calculation. And the next term will be positive because I've got 2 negatives being multiplied together. A half times 3 over 2 gives me 3 over 8. 3 over 8 divided by 6 is 3 over 48. And then I'm going to multiply that by 8, which is my 2 cubed, and I end up with 24 over 48. Which is a half again, a half x cubed. And to be honest, that manipulation of the fractions is perhaps, sorry, that should be negative coming next, is perhaps the most difficult bit of all of this, isn't it? So there we go. Nice, easy expansion again from what appears to be quite a difficult task. Now here is the trick. This is the bit that we need to be careful of. So I've got 1 over 2 plus 2x now. So I can rewrite that like before. That is 2 plus 2x to the power of minus 1. But it's not in the form 1 plus ax to the n. It's not in the form 1 plus as we had in our formula. And I can only apply this formula if it is in the form 1 plus or 1 minus something. So I first of all need to make an adjustment to this, and I need to do a bit of factorising. So watch carefully. What I need to be saying is that this is the same as, well, I want to get 1 on its own in those brackets. So I'm going to take 2 outside the brackets and say that this is the same as 2 lots of 1 plus x all to the minus 1. I've just factorised and taken 2 out so that I've got an expression that is now in the form 1 plus ax to the power of something. And then I can expand that out further and say, well, this is my laws of indices. 2 times 1 plus x all to the power of minus 1 is the same as 2 to the minus 1 times 1 plus x to the minus 1. And then as soon as I've done that, I've got this in a form that I can easily work with. So 2 to the minus 1, as we know, is a half. And then inside the brackets, I'm just going to expand out my 1 plus x to the minus 1. And you should have been practicing this, so this should be fairly easy to do. It's just going to be 1. N is minus 1, so it's going to be 1 plus minus 1 times x plus, and then it's going to be minus 1 times minus 2 over 2 times x squared. And then it's going to be minus 1 times minus 2 times minus 3 over 6, 3 factorial, x cubed plus dot 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 dot. And that is equal to a half in brackets 1 minus x plus x squared minus x cubed. Everything cancels here. 1 times 2 times 3 is the same as 6. And then it'll be a plus and then dot 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 dot. And I can leave my result like that with a half outside the brackets. That will do fine. That's a little bit more complicated because of that first step of factorising to get an expression in the brackets that begins with 1. Let's do this one more example like that. 3 minus 2x to the minus 1. Okay, we know it's a negative power, but the first thing I need to do is to rewrite this. So in brackets, to get 1 as the first term in the brackets, I'm going to take 3 outside and make that 1 minus, well, it would be 2/3 x. So the only complication here now is going to be that I've got a fraction in there, all to the minus 1. And that would give me 3 to the minus 1 times 1 minus 2/3 x, all to the minus 1. Now it's all about just using the formula again. Now 3 to the minus 1, hopefully no problems there, that's 1/3. Put that outside the brackets. And then inside the brackets, let's just go with the formula again. 1 plus. Now n here is minus 1, so it's going to be minus 1. But it's not going to be x, it's going to be minus 2/3 x. So be careful with that. And then it's going to be plus minus 1 times minus 2 over 2. And we're going to have minus 2/3 x all squared this time. And then third term, minus 1 times minus 2 times minus 3 all over 6 times minus 2/3 x all cubed. And then that will be plus dot 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 and close the brackets. And then this is just about simplifying this to make it as neat as possible, which is going to be 1/3. And then in the brackets 1 plus 2/3 x. Minus 1 times minus 2/3 is positive. And then this is also going to be a positive result here, because I've got 4 negatives all together in that expression. This all cancels down, so I end up with 4/9 x squared. That's 2/3 squared is 4/9. This is also going to be positive. The next term and the 6 and the 1 times 2 times 3 all cancels down. So I'm going to end up with 2/3 all cubed, which is 8 over 27 x cubed plus dot 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 dot. Now I guess we could leave it like that, but we might as well finish it off just for completeness, multiplying everything by a third, end up with a third, and then 2/3 times a third is 2/9. And then 4/9 times a third is 4 over 27 x squared. And then the third term, 8 over 27 times a third is 8 over 81. So there we go. A little bit fiddly. You need to watch out the calculations here, but not greatly difficult if you get your expression into the form of something times 1 plus or minus ax to the power of something. You can then just push it through the formula, the one highlighted in green, to get your result. So keep practicing, make up your own questions, take a look at questions in the textbook, but don't have any fear. It's nice and straightforward despite looking difficult. So I hope you found that series of lessons on the binomial theorem useful. Thank you so much for watching. Don't forget to like the video and subscribe to my YouTube channel, IB Maths Intense. Tell your friends I'm here, it'd be great to have them along too. And email me on ibmathsintense@gmail.com if you've got any questions, suggestions, or things you'd like to see, or if you've found any errors in any of the work that I was doing. In the meantime, enjoy your maths and take care.